In this question, you start with liquid aluminum at 983 Kelvin. You allow it to cool, solidify, and cool some more until it gets to 883 Kelvin. Your job is to calculate the energy change when this is done for 67.45 grams of aluminum. Draw out the cooling curve to see what is happening, and when you do that, you see that there are 3 steps here. The first step, A to B, you're cooling the liquid aluminum from 983 Kelvin to 933 Kelvin, where it begins to solidify. There is a temperature change here, so you can use delta H equals M times C times delta T, and the units will be in joules. From B to C, the aluminum is solidifying. There is no temperature change during a phase change, so you can't use the M times C times delta T. Here you're going to use delta H equals the delta H of the phase change times the moles of aluminum, and the delta H of the phase change here is negative the delta H of fusion. Fusion is melting, so solidification should be equal but opposite. And the units are in kilojoules. And then you go from C to D, where you cool the solid aluminum, and it goes from 933 Kelvin to 883 Kelvin. There is a temperature change, so we're back to M times C times delta T, and back to the unit of joules. There are 2 different units when you get your answer. When you calculate out these 3 quantities, you have to be sure to convert to common units at some point to get your final answer. So let's look at step 1. 67.45 grams of aluminum, which is liquid and has a specific heat of 2.80 joules per gram per Kelvin, is cooled by 50 Kelvin. Plug those values into the equation and you get minus 944 joules. On to step 2. You're going to allow the aluminum to solidify. So delta H will equal, remember, the delta H of solidification is equal but opposite to the delta H of fusion, times 2.5 moles, and you get minus 27.3 kilojoules. Now on to step 3, C to D. Plug in the values. The only one that changes from the first time we use this is the specific heat, and you get minus 3 times 10 to the 3rd joules. Now there are 3 steps here, and so the overall enthalpy change equals the enthalpy change from step 1 plus the enthalpy change from step 2 plus the enthalpy change from step 3. Plug in your values, and hopefully once again you notice that the units aren't the same. There are 1,000 joules in 1 kilojoule, and in situations like this I tend to switch to kilojoules. So now the delta H equals minus 0.944 kilojoules minus 27.3 kilojoules minus the kilojoules. So the enthalpy change is minus 31.2 kilojoules. The energy change when 67.45 grams of aluminum is cooled from 983 Kelvin to 883 Kelvin is minus 31.2 kilojoules.